Alright guys, so after you're done doing your PCR, you are going to analyze your product by gel electrophoresis. And so today I'm just going to show you how to set that up and run the gel. So first what you'll need is your agarose, not agar, okay? And you'll need to figure out the approximate size of your expected product, because with that you'll determine your percentage of the gel, the density of the gel. So as a general rule, the thicker, the more dense the gel is, the slower your product's going to run through. So I have my agarose already measured out here, and I have my water. So I'm just going to dump it into my beaker and wash it on this side. Alright, and then we can just swirl it up, mix it up a little bit in our hand. And then we'll use the microwave to heat and dissolve the gel. And so there's not really an approximate time that you should put it in there. For the most part, I just start with 30 seconds and keep my eye on it. We don't want our gel to boil over. And so then we can set up our casting tray that we'll use. So here's the casting tray that our gel will be set in. And when we want to set it, we're going to initially put it in sideways. But pouring our gel, it all stays right in here. Okay? So, looks like that's about ready. So then we'll just take it out and cool a little bit. Then we can swirl it. And so, it looks pretty clear. It's all dissolved in there. So then the biggest part about this is that you don't want any bubbles in the gel. So be very careful when you're pouring and just do it nice and slow. And make sure that you have your comb in there, because that is going to form your wells. Alright.
While waiting for your gel to dry, you're going to prepare your samples for the gel electrophoresis. You just got your PCR products from the PCR machine or from the freezer, and then you mix 3 microliters of your sample or your PCR product with 2 microliters of the loading dye.
Alright, the gel has now dried, so we can make sure the wells, we can turn the gel and make sure the wells are on the negative side, because DNA is negative and it will go towards the positive side during gel electrophoresis. And now we can pull the comb out like so. We're going to pour buffer into the gel so it reaches the fill line. Alrighty. Alright, now we're going to load the gel. So you take 5 microliters of your ladder to start. Usually you want your ladders on the left or right side of all the other wells. And then you're going to carefully load the gel. Sorry. Making sure not to poke holes in it. Alrighty, so that's one well that is loaded, and then you would go through the rest of the DNA samples, loading them, and you want to make sure to note where they are located on the gel.
Once you load all your wells, you are going to start the gel electrophoresis. you put the cover on, you want to make sure the red goes with the red here. It's a positive electrode, and you want to make sure that your DNA is up at the top because your DNA is negative and it goes towards the positive side. So you just slide it on top. And then you plug the electrodes into the machine, into the appropriate colors.
Alrighty, so we ran our gel, and it appears that the dye has run to the bottom, so we can stop it now. You're going to turn off the gel box. And you can grab the gel, being very careful not to let it slide off. And then we can walk it to the ethidium bromide now. And at this point you want to make sure you're wearing gloves because ethidium bromide is a carcinogen. So if you get it on your bare hands, it's very bad. You can put it directly in the dye. And then we'll wait 10 minutes and then wash it. And then we can take a picture of it with the UV.
Once your gel has been dyed, you can rinse it with water for a few minutes and take it out of the water and we'll go to the UV light. Then you turn the power on and you open it. Put the gel about in the center. You can turn and close it. And you're going to lock it and then you're going to turn the UV light on.
Okay, so after you're done visualizing your gel, you can print a picture on the gel dock, and then you can use this picture to analyze the size of your product. So along the sides you would have put your ladder, and then you can use the ladder key that's in the other room of the lab, or you can just simply Google 1 kV ladder, and it's pretty universal. You can get a good key. So then your products will line up with the DNA sizes in the ladder, and then you can use that to determine the size of your product. And so you can compare the product size that you look up from where your primer's buying on the biology workbench, and then you can verify whether or not you had the accurate product. And so if you ran a good gel, you had a good product out of your PCR, you should get a couple distinct bands. Size between your positive control and your experimental strain can vary. But then at the bottom you usually see the primer dimers, and that's nothing to be worried about. That's just, the nucleotide primers and then maybe leftover nucleotides from the PCR product. So yeah.
You live